In this problem, we're trying to add these two vectors together. So what we'll start by doing is drawing a parallelogram of the vectors, okay? And we'll do this just best we can. We draw one at a length of whatever 5 is. We just kind of keep that in mind as we go through. And then we draw the other one at 8, which whatever, just approximating. And then what we draw is we draw parallel lines from each side like this. Okay, and then we draw the diagonal of that parallelogram. This vector right here is my resultant vector that I'm looking for right there. Okay, so the side of this is 5, this side is 5, this side is 8, and this side right here is 8 as well. Okay, so what we know is this angle right here, okay, because if I look at it like this side over here is 50, right? This side over here is 25, and that's given in the problem statement above, right? If we do uh, opposite interior angles of parallel lines, we get that. So what's left here is the entire angle is 180 degrees. So what's left in here is 105 degrees. So now I know two sides and one angle. Okay, now this is where we're going to use the law of cosines to figure out the r vector. What I'm essentially looking for is, let me show you what we've got here, is we're looking at this triangle right here. Okay, so I've got this triangle. I'm looking for the opposite side of that triangle here as I go through and figure this out. Okay, so I'm going to use the law of cosines to figure that out, where I can find the side of that, or the length of that side, by using the two other sides. So 5 squared plus 8 squared, okay, minus 2 times 5 times 8, okay, times the cosine of the angle between those. Okay, so this is the law of cosines. It's in your book. You can find it. If you need help, just let me know. Okay, plugging that into my calculator, again, using my calculator, make sure you're in degrees when doing that, not in radians. And in using that, I get the length of that side to be 10.5, and that's going to be in kilonewtons, just like the 5 and the 8 are in kilonewtons. Okay, so using that law of cosines, I can find that opposite side of that triangle right there. Now, the angle that I'm looking for right now is going to be this angle right here, okay, because I need to find the angle at which that resultant force is in fact going. So I'm going to find that angle. I'm going to use what's called the law of sines, okay, where I do the sine of that angle, okay, divided by the side that's opposite, which for us here is 5, okay, and then I'm going to use the sine of a known angle, that'd be the sine of 105, and that's going to be divided by my side opposite, which I just found is 10.5, okay. And again, when plugging this into your calculator to solve it, you're going to want to go ahead and put in all of the decimal points that we have for this, okay? But for this guy right here, I'm going to find that the angle that I'm looking for here is 27.5 degrees, which is not the angle that I'm actually looking for here, okay? Because what I know, okay, is this angle right here, from here to here, is 50 degrees. And I want to actually figure out this angle right here. That's the one that's of more importance to me. Okay, that's the angle from the horizontal that's of interest to me, which is going to be 50 minus that 27.5. So when I go to write my resultant here, okay, with the line across the top representing that it's a vector, I'm going to write that its magnitude is 10.5 kilonewtons, and that its angle, and I draw it like this to show exactly what angle it is that I'm talking about, 22.5 degrees. Okay, and we usually do this based off of a horizontal or vertical. You can use any point, which leads us to show there's basically an infinite number of ways I could write this, right? Another example that I could do is I could go from that horizontal, okay, but do that angle all the way around, which would be 337.5 degrees. That's also an acceptable answer. Another answer I could do is 10.5 kilonewtons. And I could draw the angle like this. That angle is going to be 90 minus that 22.5, which is going to be 70 or 67.5 degrees. So again, infinite number of ways to be most exact. You would draw your little angle like that. Again, usually you can look at the picture, see what you're talking about. But as you go through and look at answers as we go through homework, recognize that your angle might be 90 degrees off or 180 degrees off or that sort of thing.